Hey guys, Anish PyMasters Scholars here. So today we'll be solving a problem involving 2D lists. We have to write a function called findClosest, which takes two parameters. The first parameter is a list, and the second parameter is an integer value called target. And the goal of this function is to return the position, or the index, of the value in this 2D list, which contains only integers, that is nearest or numerically closest to target. So we just have to return the index, or the index pair, the row and column of the value in this 2D list that's closest to target. So remember, each value in a 2D list has a two-layered index. The first index is its outer index, or its row, which is just the index of the inner list that it's in within the outer list. And then the second value is the column index, which is just the index of the value within the inner list. So for example, if we wanted to figure out the index of 10, that would be its row, which is 1, because the index of the inner list that it's in within the outer list is 1, and then its column is 2 because its index within this list, the list that it's in, the inner list that it's in, is 2. So its row is 1, column is 2. If we have to return the index of 11, that would be its row, which is 2, because the list that it's in has an index of 2 within the outer list, and then 11 within the inner list has an index of 1, because it's the second element. So let's say that if we called findClosest, we have to pass in first the list parameter, which is just L because that's the name of this 2D list, and then the target I'm going to say is 9.5. So what should be returned as a result of this function call? So which value is closest to 9.5 in this 2D list, and that is 10. So we have to return the index position of 10, which has a row of 1 and a column of 2. So 1, 2. The row and the column should be returned side by side with the space in between them. So this function does return a string with the row and the column side by side with the space. If I called findClosest, and for the target I pass in an argument of -7, which value in this list is closest to -7 would be -9. So I would return the index, or the position of -9, which has a row of 1 and a column of 1. It would return 1 and 1. So now onto the logic on how to solve this problem. So this problem's pretty straightforward. We just have to keep track of a few variables here. So obviously we have to keep track of the row, or the position of the value so far that we have found is closest to target. So the position contains the row and then the column, so we need a variable for the row, a variable for the column, and then this row and column represents the position of the value so far that we have found is closest to target for all the elements that we have traversed through so far. And then this will keep updating as we traverse through more elements until we get to the end, and then the row and column that we end up with at the end is what we're returning. And then there's also, we have to keep track of a minimum difference, and this is for comparison. So as we traverse through each element, we have to take the the absolute difference between that value and target. And if that absolute difference is less than this minimum difference, then in that case we know that there's a new value that we have found that is closer to target than what we currently have found. And so now we have to update the row and the column, and we have to update that minimum difference. So this minimum difference is always the absolute difference, because we have to find how many units away, or the distance between each value from target if we want to know how close these values are. If we only did the value in the list minus target and stored that as our difference, then in that case negative numbers would cause a very low or a very high would cause a very low or high difference. For example, -9, let's say our target was like 10, then -9 minus 10 is -19, which is a very low difference, even though -9 is very far from 10. So that's why we always use the absolute difference. And then this minimum difference needs to continuously be updated every time we find an even lower minimum difference, along with this the row and column to account to represent the position of the new value that is even closer to target than what we originally had. So you just have to keep updating the state of these variables until we get to the end. Initially though, we have to set the minimum difference row and col all to a valid data point within this list, and so we always choose the first element. So the first element always has a row of 0, a column of 0, and also a minimum difference of whatever the absolute value between that value and target is. And so this is only for baseline comparison. So we start off our row. We just automatically assume that this value right now is the minimum difference value that we found. So let's say that let's say our target was equal to 9.5. In this case, so we initially start at 4. We want to set our row column to 0 because 4 is the index of, or the position of 4 is 0, 0. And then its minimum difference is, its absolute difference between 4 and 9.5 is 5.5. That's the distance between them. And this is only for baseline comparison because we have to set the minimum difference initially to some valid difference. And so we always choose the first element, and then now as we traverse through more elements, we compare that to whatever we currently have. We compare that its difference to whatever we currently have, see if that's lower. If it is, then that means we found a closer value. So now we traverse through the 2D list. Now we're on 3. The distance between 3 and 9.5 is 6.5. 6.5 is not less than 5.5, so we do not update anything here because there's no way 3 can be closer. There's no way 3 can be the closest to 9.5. And then there's 6. We go to 6. The distance between 6 and 9.5 is 3.5. 3.5 is less than 5.5, so we know that 6 is closer to 9.5 than 4. So now we have to update that minimum difference to reflect that. So now the new minimum difference is 3.5, and we have to update the current position of the minimum difference value. So we have to update this position now to 6 to account that 6 is closer than 4 to 9.5, and so the position of 6 is row 0, column 2. And then we move to 1. And now the distance between 1 and 9.5 is 8.5. That's not less than 3.5, so we skip it. Negative 9 and 9.5 have a distance of 18.5. That's not less than 3.5. That's the farthest away from this target, so we skip it. And then the distance between 9 and 9.5 is 0.5, and that is closer than 3.5. That's lower than 3.5, so we have to update that minimum difference to 0.5. And then we have to update the position, our current position of the minimum difference element to reflect that. So 10's index would be row 1, column 2. And then we move to 2, and then 2 is obviously not closer to 9.5 than 10. The distance between 2 and 9.5 is 7.5. That's not lower than 0.5. And then we go to 11, and then the distance between 11 and 9.5 is 1.5. 1.5 is also not less than 0.5. So then, once we've traversed through each element, whatever row and column we have right now reflects the row and column of 10, because 10 is the closest element to 9.5. So that's what we will return. We will return the row and the column side by side, 1 and 2, because that's the position of 10, which is the closest value to 9.5, which is our target. So that's the logic. Now if we actually have to implement this in code, we have to first start off by defining the function. The function is called findClosest. Takes in 2 parameters. Oops. First parameter, I'm just going to call it, the first parameter is the list, which I'll call for now li. The second parameter is the target. And then so now before I traverse through the 2D list, I have to first set my variables. So I have to set my initial position to row 0, column 0, to reflect that of the first element. And then I'll set my minimum difference initially for baseline comparison to the absolute difference between the first element in the 2D list, which is list at 0 at 0 minus the target. So this is only just for a valid minimum difference value, and then as I traverse through more elements in the 2D list, I keep updating that based on their difference with target and comparing that to minimum difference. This is only for baseline. And then now as I traverse through the list, I have to make sure I use a for I in range loop, because I need to keep track of the index of the elements, or I have to keep track of the row index and the column index. So I keep updating them because that's what I'm trying to return. I have to return a string with these values. So first this is going to be a nested loop. I have to loop through the outer indices, or the lists within the 2D list. So for I in range, the length of the 2D list. So that's how many inner lists there are within that outer 2D within that 2D list. And then I have to loop through the index of every value within each of those inner lists. So for j in range, length, and then li, which is the name of the list, at I. So the length of the current inner list that we're working on. And then, so now I have to, for each value within that 2D list, I have to find their minimum, or I have to find their absolute difference with target first. So I'll just store that in a variable called current difference. That's equal to absolute value, li at I, which is the row, at j, which is the column, minus target. And then I want to compare that to the minimum difference I currently have to see if that value's difference with target is lower, or if it's closer to target than the current value that I have. And then so if the current difference is less than minimum difference, so if that value is closer to the target than the value that I currently have stored as being the closest to the target, in that case I have to update the closest value to the target. So first I have to update the minimum difference to reflect that for future comparison. So minimum difference equal to current difference. And then I have to update the position to reflect that new value that's closer to target than before. So I'll set row to I, column to j. And then once I have traversed through each element in the list, this nested loop should break. And then I have to now print row, and then with a space, and column. And then row and column are both integers, and in Python you cannot add an integer with a string because integers are not compatible to be concatenated with a string. You're going to get a type error. So I have to first cast this row to a string, and I have to cast this column to a string by using the str function. So cast the column to a string as well. And I'm not printing, I'm actually returning here. And then now I have to call this function. So I'm going to print the return of the function called find closest. And then I have to pass in a list. So I have to first define a list called list2d. That's equal to a list of values. And I'm going to pass in that list2d as the first parameter. And then since we use 9.5 as the example for the target, I'm going to use 9.5 again. And then, so obviously, what should be printed here is, in this list, it's the same one that I used as my example, 10 is closest to 9.5, so the row of 10 here is 1, the column of 10 is 2, so 1, 2 should be printed, and that is exactly what happens. And I could test it again with, say, -7. Which value is closest to -7? Here's -9. What is the position of -9? Would be row 1, column 1. And 1 and 1 is printed. So yeah, that is basically the logic for how you solve this 2D list problem. And hopefully you learned something. In the next video we're going to be going over another problem involving 2D lists where the logic is slightly more complicated.